Magnetism is a fascinating topic. You've probably learned something about magnetism already in earlier years at school, but how much do you really understand? The problem with magnetism, it's actually quite difficult, and it's not really until you go to university that you're going to get a good understanding about really what is going on. But we can go some of the way, and that's going to allow us to understand some of the important applications of magnets. Let's start with the vocab. Magnet, magnetic, magnetize, magnetism. What do they mean? What kinds of words are they? Like noun, verb, adverb, adjective? Can you match them up? Can you match up the type of word for each of these? Hopefully you had a go at that. Right, so magnet is a thing, so that's a noun. Magnetic describes the magnet, so that's an adjective. Magnetize looks like a verb, and it is. Magnetism is also a thing, you just can't touch it. It's an abstract noun. So, you could demonstrate magnetism by using a magnet to magnetize a magnetic material. What materials are magnetic? There's only 3 elements that are magnetic. Do you know which ones? Hopefully you got 1 or 2. You probably got the most famous one, iron. It's also the strongest. If you said steel, then good try, but that's actually an alloy of iron and carbon, so it gets its magnetism from the iron. The other 2 elements are nickel and cobalt. If you said neodymium, then unfortunately you fell victim to marketing. Neodymium magnets were an amazing discovery, developed by one of my professors at university as it happens, but they should be called neodymium iron boride magnets, and they get their magnetism from the iron content. The formula is Nd2Fe14b, so you can see they are mostly iron in fact. What makes these so amazing though is not how strong they are, surprisingly enough. In fact, pure iron would be stronger. Yet pure iron would be rubbish in your AirPods and your little speakers. To understand why, we need to look into it a bit more. Let's go back to iron and steel to help us understand, since those 2 are on the syllabus. In fact, let's go all the way back to basics with pure unmagnetized iron. Remember, iron is a magnetic material, but that does not mean it has been magnetized yet. This is an iron bar. Inside it are lots of little regions called magnetic domains. They all behave like little magnets. Normally, they point in random directions as I've shown. So if you look from the outside, it looks totally unmagnetized. If you place it inside a magnetic field, however, the domains will line up inside the field. Here, as you can see, the domains are pointing up and to the left. Well, most of them are. If I put the iron bar in a stronger magnetic field, even more would line up. That's how we magnetize a piece of iron. So, what's the difference between iron and steel? Well, if you remove the magnet from a piece of pure iron, this happens. All the domains went back to being random. But if you take the magnetized steel and remove the field, the domains stay how they are. It's still a magnet. So, the reason why steel and neodymium magnets seem to be strong is because they stay magnetized. Pure iron is actually stronger, but it loses its magnetism easily. To demagnetize this steel, you have three choices. You can hit it or drop it, you can heat it up, or you can place it in a solenoid and remove it slowly. We're going to look at solenoids more in another lesson, but quickly, the solenoid has an alternating current, and that gives it an alternating magnetic field. If you put the magnetized steel inside, then slowly pull it out, the steel will be magnetized one way, then the other, then back again, and as you get further away, the strength of the field will gradually get less and eventually drop to zero. Now that we've got a better understanding of magnetic materials and we understand a little bit what's going on inside, the next step really is to look at what's going on outside. And to do that, we're going to study magnetic fields. And once we understand magnetic fields, then we can look at applications and we can put these amazing little materials to good use.